Thank you for that. So my name is Mark Heslop. I'm the International Maths Subject Partner at Pearson. I've been with Pearson for about 4 years when Graham Cumming retired. And actually my role has changed in the last year. So now I support just the international schools and teachers. Um, Prior to that, I was in teaching. I spent 15 years teaching here in the UK. Actually, I was an engineer for 10 years before that, where I used to design and crash test cars for a living. So actually, mechanics is my specialty. Although I did, when I was in engineering, find my love of statistics. So this session today, we're going to be giving those insights onto the examinations, Pure 1 to 4, Mechanics and Statistics 1. Ahead, if any of you have got any resits or exam entries in the October series. I'm going to be giving you concentrating on the detail of things that you can change. There's a lot of stuff that comes out from the reports and the statistics every year that is of interest, but given an hour session, I just want to concentrate, and my aim is on the slides where I'm showing you questions, there should be something on every slide that you can take away and do something with in your classroom to affect your student outcomes. You can judge me on that at the end, but just as a quick intro, we've got a new maths guide available on our website. And when you get a copy of the presentation, anything that you need that refers to other documents, there's links here where we talk about our Mathematics A, our Mathematics B, and our Pure Maths qualification. And if you haven't seen it as yet, we have the new modular international GCSE A specification. Just to clarify, because it's questions I get asked all the time, I know there's alternative exam boards, say international GCSE, have a tendency to like to update their specifications every 2 years. So this year, in this recent one, they've introduced a non-calculator paper. We have no plans to adjust the content of our examinations. We have no plans to change the assessments that we've set out. I think that's important to teachers to have that good bank of past papers to work with that are still relevant for use with pupils. We have introduced the non-calculator, sorry, the modular version, with no plans to introduce a non-calculator paper. I think as a teacher, non-calculator assessment is really important. So we do assess it within our modular IGs and our linear IGs. So at higher tier, we might ask students to prove the rationalization of a survey. Or foundation tier, here is the result of a fraction summation or multiplication, show us all the steps. So that's how we test those non-calculator skills in a calculator assessment. But at this level, I think actually what we should be focusing on is their problem-solving skills. And that's what we tend to prefer to address in our assessments. So there's the main qualification page. If you see me looking left, by the way, it's because I have this on a separate screen. So let's go ahead. So I'm going to go through the modules, the units one by one. I'm going to pull out 2 or 3 questions from each with those insights. And it might be a question that behaved unexpectedly because there's some underlying reason for that. Might be that they didn't quite answer the question, the point in the mark scheme, and missed out on the mark. Or it may be that there's some misconception. I'm trying to pull out those key things that you can influence. So let's go ahead and let's have a look at Pure 1. Okay. So here's all the exam statistics from Pure 1. And it's quite interesting sometimes to look at the drop-off in the grades, and you can use that when you're looking at your own student script to get an idea of their working out grade if it's topics you haven't quite finished. But in terms of the topics I'm going to look at here, so let's just highlight them. So we've got question 1, question 3, question 4, question 8, and question 10. So questions 1 and questions 10 on the integration, there's a definite lack of understanding of a key topic that's a barrier of entry to the rest of the question. Question 4 and 8, I'm going to talk about easy marks that students are losing because they're just not answering the questions in the right way. And question 9, I am going to talk about how to improve their exam technique. So let's dive straight in. I should say, before we dive straight in, this year, Pearson launched regional maths papers for the Pure 1 and the Pure 2. It wasn't a defined time zone. It was certain areas were given a regional paper, and we use that as a quality control in terms of the statistics. That would be very similar questions between the 2 papers, just to see how things perform in under the same exam circumstances. And from this paper, I'm only really going to look at only question 10 on trig graphs. Pulls out something new I haven't really said for the home papers. So here's that question one, and it's a pure revision point on this one. So we're asked to find an integration, an indefinite integral, giving each term its simplest form. And it came through, this issue came through on the regional papers as well on 3 separate questions, 1, 3, and 7a. Okay. Some students struggle to write a negative power before integrating t. Centres need to ensure candidates have plenty of practice of integrating negative powers. And I think this is one of those skills that we're concentrating on the harder stuff. We almost assume that the students know this. And what I'm saying to you is it's coming through as a pattern in the exam, that it's worthwhile spending a little bit of time revising those fractional indices, negative indices, surd skills with your students, especially if you've got research students this autumn. It'd be interesting if you throw into the chat, have you got any students entering for the autumn term? Is it a research paper, or is it the first time they're entering a paper? So do, while I'm talking, throw that into the chat. And I've got some resources for you later on that I can show you that can help your students with those. So, question 3, an interesting one, an easy mark loss. There was something else interesting about this paper. So, on each diagram, show clearly the coordinates of all the points where the curve cuts or touches the coordinate axis. And the examiners are actually very, very generous. So a point here, if it was 3, 0, or even if this one here, -1, 0, they're actually saying the mark schemes, we could let them get away with just labeling that as -1. We don't mind if actually the coordinates are the wrong way around, but as long as it's clear what their intention is, that's, we don't want to over penalize students for this one. But they do need to make sure that they need to indicate those coordinates of intersection, or they're just throwing away marks. But there was something interesting that also came out of this. So part A was actually very well done. So translations. Stretches and reflections. So a stretch parallel to the x-axis, reflecting in the y-axis, was the one where the student struggled. And I'm going to say here, this mark here, I've highlighted this 0.18. That was in the bottom 10 performing marks on the paper. If there's a topic on this one that you want to refresh, and I've got the marks here, so that reflection in the y-axis was actually what the students struggled with. We did actually allow some follow-through in terms of the coordinates themselves, but as a topic, if you're revising for research students, reflections on the y-axis or stretches parallel to the y-axis is a key topic to focus on in their revision. Okay, right, interesting one. Again, I'm not going to dwell too much on all the detail of the question, but suffice to say, questions involving TAN, whether it is in sketching graphs, whether it is transformations of graphs, or whether it is further up in the syllabus where we're using trigonometric identities, students are less comfortable working with tan than they are with sine and cosine. So maybe it's just one to think about in our schemes of work. How much time do we devote to this? Is it that we need to sneak an extra lesson in when we're covering this kind of work involving tan? Just a food for thought on that one. Definitely one that students struggle with, and it's come through from previous examinations as well. Okay, so moving on to question 10. So here we've actually got a calculus topic. So f of x is this. Find the equation, and then find the equation of the normal. Okay, the interesting part was the examiner stated again, in part A, most candidates successfully found the gradient. However, a significant proportion of candidates were unable to evaluate the fractional powers when evaluating the gradient. So we've got this barrier coming through, and it's not necessarily just at lower grade students. The statistics say actually it's for some of your grade A and grade B students, that this is just that skill again of fractions, indices, recognizing when a surd and what the power that goes with it needs to be to actually gain access to this question. I'm going to skip back a little bit. Okay. So now we're actually talking about, there's a very similar question, a very similar issue on our paper. One of the themes that I am going to run through in this presentation with you is the levels of proof that we have on our examinations. And one of them is show that. So we have effectively verify that, show that, prove that, and then the more formal techniques of proof. And I'm going to show you where you can get some resources. I think students have a mental block, and I'm going to ask you a question a bit. I think you'll find the answer quite surprising. But the examiners say when it comes to show that questions, so show that k squared plus 26k plus 169 equals 0, the students are forgetting, here we go, a small number missed the equals 0 on in their final line. This is very similar on the R paper, and there's another example of this later on. So can you stress to your students that when we say show that and give them an equation, they must have the full equation as their final answer. We can't just make the assumption, oh yes, and therefore it equals 0. It has to be seen in their script. I always used to say to my students, it's okay to not get the marks for the topics that you can't do. It's not okay to get the mark, to miss the marks on the topics that you can do. You just didn't quite finish it off. The students have done all the hard work by the time they've arrived at the k squared expression. They just need to make sure they're finishing it off. Okay, question 8, same issue again. A common mistake this time with the question 8. So further down in the paper, so the previous one was 4, this one is 8. We're actually seeing it more common in later on in the paper when students may be rushing, feel they're a bit more under time pressure. So those are the key points on Pure 1 and Pure 1R. I'm going to move on to Pure 2, but I will come back and summarize these points at the end. So in terms of Pure 2, what we're going to have a look at here is the factor and remainder theorem, which is definitely, we actually cover some issues on proof here that I want to highlight to you. And also algebraic proof, does what it says on the tin. And then finally, just some advice from the examiners on how students should approach geometry questions. In terms of the R paper, we've got laws on logarithms. And I picked this one up because it was one of the lowest marks on the paper. And again, that is related to proof. So let's go back into that Pure 2. So here's question 4. Okay. So state the remainder. We've got to show that k equals 11, and then hence fully factorize and find the real number of solutions to the equation, giving a reason for your answer. And the examiners say the vast majority of candidates were able to gain at least 6 marks on this question, but there were many who did not know how to justify their final answer. Prove that questions, we're going to require a final statement. Show that questions, we don't necessarily need it. But then this one, giving a reason for your answer, if they're not putting a statement down, they're not going to get that final mark. So a calculation of the discriminant and a conclusion that it of what that discriminant means, there are no real roots, is what we're expecting to see. And you can see that in the grade statistics. So here's part C, II, and you can see that only 25% of all candidates actually manage to score that final mark. And we really drop off once we get below, say, a grade A student. They've done all the hard work to this point. 0.49 got the preceding mark, grade B candidates. Only 0.31 got the final mark. This is the mark scheme. So we're going to solve them simultaneously, factorize it. So attempt to factorize this, realize that we need to use the discriminant. So attempt to find the number of roots, potentially by using the discriminant. States that x squared has no roots with a reason, for instance, that the discriminant is less than 0 is acceptable, and then has a concluding statement that it only has one root. And it's this bit here that I'm going to say that students need to focus on and practice on. Final concluding statements come through really strongly from this year's evaluation of the exams. Okay, right. Now we're on to a formal proof question. So, given that x, y are positive numbers such that this inequality, prove that y is greater than x. And the second one, using a counterexample, show that the result in part A is not true for all real numbers. So we've got part A and we've got part B. Which of those two do you think the students found the hardest? Please just pop, it gives me a chance to have a cup of tea. Please just pop into the chat A or B as to which one you think the students found the hardest. A. Thank you, Zainel, for being the first one. Let's see who else is going to call it. Got another couple of seconds. Brilliant, A. Let's go for one more vote. And we'll go with the wisdom of crowds, as they say. Okay, so here we go. Here's the actual exam statistics. Students performed better on question A. I'm sorry, ladies and gentlemen, I kind of led you into that one. Students performed better on an algebraic proof than on a counterexample. And I think we need to expose students to more of this. I'm going to say the final mark on A is where they drop down. So it's writing that concluding statement, and they've done all the hard work by here. But here you go. Here's our grade A star students. So even A star students, 60% of them got to the third mark, but only 7% of them could get the final mark on A. And then 7% of them could actually attempt the start of B. And here's the mark scheme. So this is where which is really quite remarkable. So this is where on A, that actually students can probably do more than we think on proof. They're getting a long way through and good reliability at answering to this point and getting to here. So the third mark, dependent method as one, but it's writing a concluding statement. And I've got some ideas of where you can get examples of questions from that the students can practice with. When it comes to counterexample, and this came through last year, where we asked students to do a proof by exhaustion. There was only 4 combinations they needed to check. It was very simple. But again, students were better at algebraic proof than they were actually some of the techniques that we maybe assume they will find quite straightforward. And I think it's an important lesson for our exam technique and where we focus our efforts. This is the kind of level that we expect. So as x and y are positive numbers, x minus y is greater than 0, and therefore y is greater than x. So that concluding statement on the first one, and then finding a suitable counterexample. So they've changed it in here for all real numbers. So it includes negatives. So we just needed to try one or both of negatives to find it quite quickly, a counterexample that doesn't work. I think it's really interesting how students did on that one. And it's definitely one to take back to the classroom in terms of talking to your colleagues about where we think students might find it difficult and where they're actually finding it difficult. Certainly practice on the concluding statement, but some techniques we think are straightforward, but the students are not finding it that way. Okay. Next question, easy wins. So this was a question of whether students had to find the center and radius of a circle. And the center of a second circle, or circle was given here, proved that the circles C1 and C2 neither touch nor intersect. And a lot of students went down, I'm going to focus on this part, a very algebraic approach, trying to solve them simultaneously, so elimination, forming a quadratic, showing that the quadratic had no roots and using that to conclude. And what the examiners actually said was, a sketch would have been useful in this part of it, as those that sketch the circles were often able to see a much simpler approach to this part of the question using the distances between the centers. So a quick sketch, knowing what the radii of the circles are, and actually just then seeing, I can use Pythagoras to find the distance between the two centers and show that the summation of the radii is less than the distance between the centers. We can use that to prove. Just coordinate geometry, and again with vectors that I'm going to show shortly, is where we need to be bringing in, instilling in our students. A quick sketch can often reveal a much more efficient, elegant solution. I always think the best solution in maths is the one that's the simplest, it's elegant. Why use 2 pages to do some work when you can do it in half a page? Drawing diagrams is a key technique. Okay, so here we are also, to a degree, looking at proof. So very interesting one here, and it's this part A where students actually cropped up with one of the lowest scoring marks on the paper. So not necessarily, we've just got asking a student to verify a value. Then we ask them to show that something is true, and hence using algebra, giving your answer in its simplest form. Actually, the mark that student fell down on in here was the second mark in this first part, verify, T the solution. Here you go. Here's your A-star candidates. Okay. They nearly all got the first mark on this. Only 50% of even A-star candidates are actually getting the second mark of a verify that. And it drops off considerably more after that. Why? Well, what the examiners expected this. So they say, part A was not well done. To verify that a value is a solution of an equation involves substituting into an equation and demonstrating that it satisfies the equation. I think students understand the principles of that. But we just need to step up a little bit for the last part. So, for example, verifying t equals 4 as a solution to the equation involves substituting t equals 4 to get 3 log to the base 2 of 8 minus 2 log to the base 2 of 4, and calculating its value 3 times 2 minus 2 minus 1 equals 7, and a minimal conclusion. And the minimal conclusion could be, you see in the mark scheme, a student putting a tick and verify that question to show that they had arrived at the required conclusion. So we've got verify that, show that, and those are the ones that students weren't putting equals 0 or the full form of the equation at the end. And we've got prove that. Prove that statement, prove that problems. Formal proof requires a statement at the end. So I would say that's a mark that students are losing needlessly. Okay, pure 3. We're doing okay for time. Just got to keep a little bit of an eye on it. There was a couple of topics in here that stood out to me. Less so this year. So last year when I did the exam evaluation, I was finding that there were topics that a lot of students were finding, quite a few topics that students were finding unexpectedly hard that maybe we just glossed over. That's definitely less the case. There's only a couple left now that have popped up this year. It is true on the statistics side, certainly, and I'm going to go through that shortly. But there are fewer topics this year in the pure side where it stuck out that it's okay when we have a question that's hard. We know it's a hard question. It's when there's a question we think, actually, the students should find this easy, but there is some barrier of entry in here. It may well be those indices, but that feels a relatively quick fix on the pure 1 and the pure 2. This one, I'm going to say, functions and their inverses. There is one exam technique in here that I need to flag up to you, where they're not quite hitting the base in terms of the mark schemes. But inverse functions is definitely one where I think even higher ability students struggle to rearrange it. And trigonometric identities and equations. I'm going to talk to you, not necessarily the problem was with the trigonometric functions, but I wanted to highlight something to you in the way that we structure exam papers that may be a bit subtle to some students, and it's worthwhile re-highlighting. Okay. So the functions f and g are defined by f of x, g of x. Find f to the minus 1 of 22. That was okay. Use the differentiation to prove that g is an increasing function. So we're after a prove that statement here. So we're after a concluding statement. The students definitely fell down on g to the minus 1, and they definitely fell down to find the range of fg. Okay, so the examiners say on part B, I'm going to skip around a little bit. Many candidates missed out on the third mark by not making a comment which linked their differentiation to the task of the question, i.e. proving g was an increasing function. I'm going to show you the mark scheme to that in a second. But I want to come back to part C, find g to the minus 1 of x. So firstly, the students struggled on the skills. I can show you the exam statistics in a second. Secondly, there was something very common that students missed off that meant a mark was withheld. can you throw into the chat for me, please, that you might think was very common for students to miss off? I'm just going to have a sip of tea. Domain. Paul has hit it straight away. I'll show you the questions here. I'm just going to mention that part B. So they have found g dash of x, and what we want is a minimal statement set recognizing that g dash of x is positive and hence it is increasing. That's what is needed to get that final mark. Say, reflecting upon what we've done in the maths and what it means. But then in this inverse function one, it's this part here. Domain is 0, x is greater than 0 and less than 3. And there are a number of formats that they could write that in, but that here is the most efficient one. You will see in some mark schemes it is condoned that they have missed off the domain. It's one of those marks that can be applied and they're sometimes not applied if we don't want to over penalize students. It might be that they needed a mark elsewhere on another question. They thought the a function question is good, but we actually need a mark, an easy mark maybe elsewhere in another question to help balance the difficulty of the paper. We might see in some papers, we don't require them to write the domain. You need to tell your students it should be assumed that they should write the domain of a function every single time, because there will be cases if they miss it off where they are penalized for doing so. Just want to really stress to your students. There's the comments about the increasing function. I'm going to show you those exam statistics. So I've gone down to part C here, that mark on the domain. So here's the C, the method mark for rearranging. Cursor has disappeared, and the accuracy mark and the B1 mark for the domain. So you can see it was the B1 mark that we were struggling with. But I am also going to say that, take for instance your grade A students, only 75% of them, 3/4 of them, managed to successfully do a rearrangement of this function for an inverse function. And it gets a lot worse when you get below that. Okay, so take for instance your grade C students, only 2/3 of grade C students could do that. Now this is something we asked them to do at international GCSE and UK GCSE level. And perhaps it's something that we just need to revise on, but certainly we do need statements at the end of a show that I'll prove that question and a domain stated when we ask them, say, for an inverse function. And I'd like you to stress that to your pupils. Okay, let's move on. Right. So I've already said that students struggle a little bit with tan functions, but that's not the point of this question. So we've got A and B. So given that equation, show that, and then hence or otherwise solve for this range, this equation. And the examiner said the question was one of the more challenging ones in the paper, although over a quarter were still able to score 4 marks. Part B, many candidates did not understand that the question from part A could be used, even though we've said hence or otherwise. So firstly, we need to encourage that. Secondly, I want to just highlight a difference to you in the structure of exam questions that you may or may not realize. If you're an exam marker on here, you probably know it already. So we sometimes label our question parts A, B, C, and the A part might have an I and an I. It's quite sweet. When I talk to the examiners in meetings, they talk about dotty I and dotty II. It's just the language they use to make it clear what they're talking about. But so A may have I and II, but you might see the main parts of the question labeled dotty I, dotty II, dotty II. What is the difference between when the main parts of the question labeled A, B, and C are I, or I? If you can throw me something into the chat, it would be quite interesting. I think there's a subtle one. I give it 10 seconds and then I'll put you out of your misery. Diana, it's a good question. Good point. More scaffolding. No, it's not actually the scaffolding. Okay. I'll let you in on something then. Okay. If we label something parts A, B, and C, we generally speaking intend them to use the part A. Yeah, and the information is Zainab as well. The information in part A in part B. So we actually say here, use the information in part A. Have a look at exams when you've gone away from this. And then hence or otherwise, which is really instruction to use what you've done before, if you can, we ask for an I and a dotty I, and they're an I and dotty I because they are actually, we don't need the information here for the second one from the first one. If we structure it the other way around, so this is, we wouldn't necessarily include two different topics in a question. These are both logarithm topics, but there is an underlying structure that's worthwhile pointing out to students. Because this is an I and an II, we are not intending them to use the information in part A in part B. We are just testing two aspects of logarithms in the same questions. And I think that helps knowledge of this, helps clarify to students that, some students think, how is this related to this? Well, it's an I and an II. It's not. We're just testing log skills in two different ways. Please do feel free to throw into the chat if you weren't aware of this previously, but I think that's a really useful point to pass on to our students. Okay, Pure 4. Pure 4 is an interesting one. Yeah, okay, so vectors. I've got a comment on vectors about how we can improve the way, and actually a very simple fix of how we can improve what the students do on vectors. 3, I'm going to talk about, there's a misconception that's come out this year on implicit differentiation, but it probably isn't what you think it is. And question 8, I am going to talk about those proof techniques again. It's that theme running through here. If you gave me one topic I would love students to be able to do better on, it's proof. And I'm going to show you a question in a little while next to a proof question, and you're going to say, well, that question is harder than the proof. And yet students did better in the other questions. And I can show you this consistently. I think it's partly lack of practice on proof, and I think it's just confidence to have a go. I think some students, a lot of students, maybe too many students, look at a proof question and go, I'm not going to be able to finish that, so I'm just going to move on to the next question. I'm actually not realizing that they could actually get quite a few steps through the proof without actually coming up against any real barriers. Zainab, we don't actually have any formal training on proof at the moment in time, but it's something I can, if you put it on your feedback form, I have actually got some summary slides on here of what the different techniques of proof are, and there's actually fewer than you think that would test people. But please do put it on your feedback form if you think it's something that your teachers would benefit from. Okay, so general guidance. So this comes for any vectors question. I'm going to say whether it's 2D or 3D. The examiners say it's been mentioned in previous examiners' reports that the use of a diagram would aid candidates' understanding of a question, and this was such a case. Now, I know students are reluctant to draw diagrams to something that's 3D, but if you model it in class of what that might look like to illustrate and help frame the information in the student's mind, they're more likely to be doing it in an exam. And what I'm talking about here is, given that OC is a perpendicular to BC, we're talking about literally just drawing two perpendicular lines, and with the vectors labeled on them, that can often help a student find their way into a question. That just beginning element, that's often the hardest part on this one. Likewise, those questions where we're asked students to find, here's a point and a point moving along the line, what is the closest distance? Even a diagram can just help them recognize that they're trying to find a perpendicular with a dot product. So general guidance on, say, coordinate geometry is a quick sketch, can help them find an easier solution. And certainly vector problems, students should be doing a rough sketch on every single question. A lot of correlation between those that draw a diagram and those that get more marks. Okay, so here is an implicit differentiation question. Curve defined by the equation. Here we go. Find an equation of the normal to C at the point 25 giving your answer in the form ax plus by plus c equals 0, where a, b, and c are integers. We are still seeing some evidence of students not leaving their work and a final answer in the form required in the question, and I will flip back to the vectors before I say this. The examiners did say on vectors questions that students are now generally working in terms of the form required in the question, so are leaving their answer in the form required in the question. So if it says leave it in IJK form, they are doing that. It's okay to use column vectors. It's okay here to do IJK format. Generally speaking, if they should leave it in the form of the answer of the information in the question, or they need to be mindful of if a certain form is being asked for in mechanics, for instance. I'm going to show you that, but it's okay in their working to work in an alternative form that they're more comfortable with. Okay, so given these terms in this original equation, which one do you think caused the most difficulty in terms of the differentiation? Please throw something into the chat. Let's see who's going to have a go in the chat. You guys are great for engaging in the chat. I'm enjoying this. If anyone's going to be the first one into the chat of the term that the students found had an unexpected level of difficulty with, shall we say. XY, thank you, Omaros. Let's see if anyone else is going to throw an alternative. Don't be afraid to go with something different. That wisdom of crowds on the previous one where everyone said A and it was B. We're sneaky as teachers, aren't we? Rearranging, finding the normal. No, I'm asking for just differentiating, applying the product rule for Betsy. Okay, I will let you out of your misery. The 9. The examiner said there were too many instances of a failure to differentiate the 9. Now then, I think if we just had an equation y equals 3x plus 9, I don't think students would have had any difficulty differentiating that. I think we just need to remind them when we start to bring in, especially in those later exam questions that are harder and they're just really concentrating to recall those difficult techniques, I think students sometimes forget the easy techniques. And I think we should just remind them occasionally, constants do differentiate to 0. And it's could be worth its weight in gold for some of your students. I do see it that easier techniques get glossed over and students make mistakes where they wouldn't have done it. That had just been that technique used on a simpler question earlier on the paper, and then maybe focused on, say, product rule, quotient rule, implicit differentiation. Implicit differentiation, one of my all-time favorite topics to teach in terms of here's an efficient way to do a topic. So I used to love differentiating the equation of a circle in implicit form and a Cartesian form and showing them which way is easier, ladies and gentlemen. Just a lovely topic to teach. Yeah, just be careful of that. Equals 9. Okay. So, an interesting question here. So we've got binomial expansion. And the examiners did say the modal score here was 5 out of 8 marks. So we've got part A to do a binomial expansion and use proof by contradiction to prove that the curve with the equation this does not intersect with this equation here, where A and B are constants found in part A. So the examiners did say part B was very discriminating at the very highest grade. Most candidates could score only the first mark for setting up a contradiction. I'm going to fire up the mark scheme. But let's have those marks here. Okay. A reminder, so as a formal technique, proof by contradiction, we do require them to make a statement of the contradiction at the start, and then, as with the other proof techniques, a concluding statement at the end. And actually, if you look at this, even if students couldn't get this mark, they could access a lot of students realize that they're trying to solve these simultaneously, but they could actually get at least the method marks and the accuracy mark. But again, I think the topic of proof put them off. All we're asking students to do is try and solve two equations simultaneously. I don't see any reason why your grade B and above student couldn't get these 2 marks. But look at this. For that second method mark here, where they're actually attempting to do some work with it, only 3% of your grade A students could do this. It is interesting that 92% of them set up the contradiction, which is in some ways the hardest part of this, of realizing what we've got to do, but then couldn't progress any further with the math. And I wonder if they just moved on to the next question when they could have easily picked up the first 3 marks. But it's a minimal statement of contradiction and conclusion here that we're after. So I think, again, those formal proofs of contradiction, counterexample, exhaustion are the ones we just need a bit of practice on. And don't get me wrong, my experience is even just a little bit of practice on these with these students can make a huge difference. Okay, so on to mechanics. So I'm going to pull out 3 questions in here. So question 5, I'm mainly going to talk about exam technique. Question 7, again, I'm going to talk about exam technique and a little bit from GCSE knowledge. And I'm going to pull out question 8 as a good one to use in class during your revision. So I'm going to go, this was question 5, lovely question about velocity time graphs. Some information given. Find the distance fallen by P in the first 5 seconds. Okay, and the parachute, a box fell vertically and freely under gravity for 5 seconds, then the parachute opens. Just a particle under gravity, initial velocity 0. Bit of SUVAT, love a bit of SUVAT. Here's the exam statistics. Ooh, this mark was in the bottom 10% of marks on the paper. Here's the mark scheme. So it's UT plus a half AT squared. U is 0. Why is it that only, so for even on A-star students, 99% of them could do the maths of the question, only 40% of them got that mark? Please suggest something into the chat. Yeah, well, almost not a rounding error, an error, a rounding off error, an error on the rounding. We're using G. We use G as 9.8, slightly to simplify things in mechanics. I had a physics teacher once tell all the maths students that they were supposed to be using 9.81 and the maths department was wrong. No, we're using 9.8. Answers, any numerical answer which comes from using G, 9.8, should be given to 2 or 3 significant figures. Certainly not more than 3. And if the students do more, they will be penalized. But the rule says over accuracy or under accuracy of correct answers should only be penalized once per complete question. So I'm actually guessing the students continue to make this error here. We actually don't want to over penalize students for this kind of thing. Examiners are, marked positively. So it tends to get applied. Well, it gets applied to the first instance of it occurring on a question. And that's why you see this here. The fact that it appears here in such a magnitude tells me that a huge chunk of students, when an equation involves a G, are losing a very easy mark. Please remind your students of that. Vectors, again. Examiners said on here, so it's particles moving. So boats are modeled as a particle. Fine in terms of I and J. It is okay to work in column vector format as long as the final answer is in I and J format. But it's part E here that was causing the difficulty. Here we go. Here's part E. Find the distance between the boats when the bearing of B from A is 225 degrees. Actually came through as a comment in one of the pure papers. Bearings, please. Worthwhile refreshing bearings with your students as a concept, where it's measured from. And I bet if students drew a diagram on this one, they were more likely to get it right. Certainly, the bit B from the bearing of B from A is 225 degrees. A quick sketch helps to sort that information out. But please, please, please remind your students of how bearings are measured from north clockwise as 3 figures. 3 figures almost becomes less relevant in what we do here. Excuse me. Yeah, bearings are a key topic. Okay. And that comment, draw a diagram to visualize it. And then the final question on mechanics is an object on a slope. And the situation is that the object is being pulled up the slope by B. B hits the floor. And then we ask at the end, once B hits the floor, how much further A travels up the slope? I think this is a really good question to explore in class. So a lot of students didn't realize that they needed to create a new acceleration stroke deceleration. Some of them just said it decelerated at G rather than working out involving friction. But I think the concept that's really worth exploring in class is the one that if you have an object moving up a slope, coming to a halt, and then the component of gravity is sufficient to pull it back down the slope. A common question is, fire an object up a slope, how long does it take to come back down to its original position? A lot of students will just apply the same acceleration in this direction down the slope to the entire situation. A lot of students don't realize that the acceleration changes when the velocity changes around. So friction always opposes velocity. So when the object is moving up the slope, both friction and the component of gravity parallel to the slope are pointing down the slope. So it's the sum of those two. When it's actually moving down the slope, we have the component of gravity pulling it down the slope, but friction is pointing in this direction. So it's the difference between component of gravity parallel to the slope and friction when it's moving down the slope. So I think this is just a good question in class that can uncover a few misconceptions in the way students think about this, and we can explore it in different ways. So yeah, definitely a good question to use as a lesson starter. Moving on to the statistics, something that came through from last year was to revise those GCSE level topics and international GCSE level topics. And some of the questions at the start of the paper last year, and to a degree this year, were actually the worst performing. Slightly different reason for it this year, but certainly in terms of quartiles, definitely a problem. And in terms of linear regression, I'm going to talk to you about exam technique. So in terms of this question one, we're really just revising those international GCSE level skills. And I'm not going to go through it in too much detail. Suffice to say, show that there is only one outlier. We're going to show that question. Students need to realize that just because we're in statistics doesn't mean that they shouldn't be applying those show that techniques that we apply in the pure side of the syllabus. So they did say incorrect values for part C could be followed through. A few students failed to give sufficient detail in their show that question to be awarded the final mark. Usually this was because after identifying enough at the lower and upper boundary, students failed to state that 85 was the only outlier, which was required as the question asked students to show that there was only one outlier. So we've got to put a concluding statement. So that was part C. When it came to, part C, that was part B, and show that there's only one outlier. Part D, on the same grid, draw a box plot for the height of the birch trees. And the examiners actually said, and this is quite surprising, some drew whiskers that ended in the wrong place, some made errors in plotting the quartiles, and some actually failed to plot the outlier. Please just spend a moment revising. Histograms certainly came through last year. Finding the mean from group data came through last year from a histogram, and quartile. Some of those basic skills that we assume that students may still have. And then part E, comment on the differences. So at this level, students need to realize that a question like this requires context is the important thing on the content. So if we were asking students to comment on a regression line, we wouldn't just say there is a correlation between the two. We'd be expecting a little bit more. It would say there's a positive correlation, which means that as hours of sunlight in the day go up in hours, it's good to quote the context in the units. Plants grow taller measured in meters. So context and units is what we expect in these kind of explanations. Here was a regression one. Now, regression is actually pretty well done, but the examiners did say, show that the equation of the regression line, so it was a show that issue was also evident on linear regression, and if in doubt, there are examples of the working that they need to see in the mark scheme. But interestingly, on many of these, the examiners also said, C, lost the final accuracy mark as they failed to give values to the required degree of accuracy. Now, even in here, we actually said given to 3 significant figures, and there is guidance on the front of the paper. So in part B, students should be reminded that when values are required from tables, so we're looking at values in tables, they need to be to 4 decimal places. And the guidance on the front of the exam paper says values from statistical tables should be quoted in full. That's 4 significant figures. If a calculator is used instead of the tables, the value should be given to an equivalent degree of accuracy. Inexact answers should be given to 3 significant figures unless otherwise stated. Please remind your students of this. So in summary, general guidance, diagrams on vectors and coordinate geometry. We need to differentiate between verify that, so we might just put a tick at the end to indicate that it's verified, show that where they've got to arrive at the exact form of the equation, and prove that where we require a concluding statement, and for proof by contradiction, an introductory statement for set up the contradiction. We need to refresh bearings for both the pure and the applied side, and algebraic proof. Now, in terms of a summary for each of the units that I've gone through today, surds and indices and trig graphs for pure, so confidence with tan, stating points touching with axes and prove the form of an equation to equal 0. Pure 2, coordinate geometry sketches, and candidates should take care when using a calculator to find the steps of equations, especially when the question demands a show using algebra or show all the steps of your working. Pure 3, definitely refresh inverse functions and stating the domain as a matter of course. Pure 4, diagrams for vectors, and just a reminder on some of the simpler things in implicit differentiation. Mechanics 1, making sure we're using the required degree of accuracy. And statistics 1, revise those international GCSE topics, histograms and box plots, and again, the required degree of accuracy. So I'm just going to do a few extra slides here at the end of proof and some resources for you, just a reminder on proof. So in terms of Pure 1, what do we expect students to do? We expect them to verify that, show that, prove that. And like we've said, those stages of proof. In Pure 2, that's where we need to be bringing in and engaging with proof by exhaustion and disproof by counterexample. We don't formally have any new proof techniques in Pure 3, but this is where we do often apply it to trigonometric identities with an equivalent symbol in between. And students are reminded that they cannot manipulate and treat it as an equation. And in Pure 4, that's where we bring in proof by contradiction. I'm going to go back to that proof question in Pure 1. So here we go, just to remind you of those statistics. And I'm going to move that over to the left-hand side in a second and fire up a trigonometric topic. So here we go. Here's that proof question. Here is quite an involved question 8 from the same paper, where the students have got to do quite a bit of modeling. They've got to manipulate, they've got to use trigonometric identities. And here's the rub of the problem. Algebraic proof, question 5, students scored on average 22% of the marks. Question 8, students on average scored 45% of the marks. Now, I don't think there's anyone on this call that will actually tell me that this proof question is actually harder than this trick question. I think students find them harder, but I think that's what we need to be exposing to them and actually almost convincing ourselves that they can actually do this kind of thing. I don't think it's going to be as big a step up to get them to be able to do proof well as it is a step up to get them to be able to do trigonometric identities well. Where can we get resources from? Okay. If you haven't got access to Exam Wizard, I would recommend after this call, you go see your exams officer and get Edexcel online. I think Exam Wizard is the most useful tool, especially if you're coming over to a new specification. It's that ability to pull out a specification point and filter by those questions. Okay, I can see with this exam board the range of questions that are being asked on that particular specification point. But we can filter here for proof questions. So there's 30 questions on there from the international spec at the moment. You can see the mark schemes, you can see the examiner's report, You can pull groups of them together as Word documents to give to students. You can leave the mark scheme off the end of it if you wish. It's very good. And as a second source of proof questions, proof at the same level is in the UK A-level maths specification. And on Exam Wizard, on that top left-hand side, you can actually choose the UK specification and filter for proof as well for exactly the same kind of questions. It's a really good alternative source of questions. And just to go back to some of those skills that I said needed practicing in terms of resources for those, things like your SIRs, your indices, we actually have a transition. And this is mainly to support those research students whose exams are coming up in a few weeks. We have a transition website. Now, I actually developed a lot of this stuff when I was working on the UK side, actually before I joined Pearson. And what we did was we took all those international GCSE level skills and GCSE level skills that are common to the first year of the IS or AS course, SIRs, indices, fractions, solving simultaneous and nonlinear simultaneous equations. And we did examples. So I walked through the examples of the textbooks, and it's all completely relevant to supporting students on the international AS level and A level. You can use it as summer work. You can use it as intervention work. You can actually use it in year 11 to boost students up because it's their topics with slightly harder questions. So for each of the topics, there is effectively a video. If you're in a mood, there's about 10 hours of me waffling on, talking through the examples. So I've taken the textbook examples and walked through them with commentary to make sure we're meeting students' needs who prefer that kind of style. We've also put together exam questions. I'll show you what those look like. So it's those more basic exam questions. So here's an example of the video with me wittering on. And then when it comes to the exam questions, we've brought in examples that they can use to answer those questions, and then those basic questions on rationalizing SIRs, fractional indices, etc. So it's all perfectly relevant to students studying the international AS level and A level. I will at the start of the video say, this refers to example 15 from page 54. That's the UK textbook, but it's the same example in the international textbook. I'm not sure I have the will to re-record 10 hours of videos. I think 121 videos. But please do make use of them. In terms of upcoming training that we've got for you, so we have next week, we've got the equivalent to this session for the international GCSE. I'll be doing 2 sessions on the 1st of October for effectively the main papers, and then 2 sessions on the 8th of October for the regional papers that are a little bit spread out. Yep, same kind of thing here, but I will be spending more emphasis on the crossover questions between foundation and higher tier, and using that to help you make tiering decisions. And then in the weeks that follow that, we have understanding and improving the outcomes of international A level. We have getting ready to teach the international GCSE course and getting ready to teach the international A level course. And I am perfectly to time, 1 minute to go. If you've got any questions, please do either throw it into the chat or drop it into the feedback form. I hope this session has been useful and I've hit that mark of having something on every slide with a question that you can take back to your classroom and do something with. Please do follow me on LinkedIn. This is where we're making a lot of the announcements. If you got any feedback from the summer examinations, please put it onto the feedback form. I'd love to hear what you thought. Anything you thought went well, anything you think that we could be doing better as an exam board. And hopefully I'll get to see a few of you face to face this year in my travels around the world. But I do hope that that's actually been a useful session. And thank you very much for joining us and giving up your time. I'm aware for some of you, it's well into the evening now. So, yep. We shall see you again soon, but please throw any questions into the chat, or probably better at this time, into the feedback form. And that's me. But yeah, I'll leave that slide on the screen in case you want to scan the LinkedIn code. Thanks, everybody.